What's up, guys, and welcome to our dynamics project about finding the friction factor with Will Bland, Eli Freeman, and Talib Spearman. So a little bit about the purpose of this study and the background. Well, the purpose of this study was to understand the relationship between an object's mass, potential energy, and kinetic energy, the velocity of an object, and the friction force caused by all of these components. And we did this utilizing Tracker, Excel, and MATLAB codes. And this study came from the question of how different sized vehicles drive on different roads, such as dirt roads or asphalt roads. This question blossomed into the study of how friction is specifically affected by the different mass and velocities of vehicles on different materials. So just like some problems we saw over the semester that kind of reminded us of this, sometimes we'd have a car going down a hill, and we'd want to be able to find like the braking force so that it would stop by a certain time, right? And then of course, like we remember back in physics ones where we'd have your classic box sliding down a hill, and then you have a friction, acting against the force, right? So moving on, let's get a little bit of project information. So we wanted to find the difference in friction against these two different toy cars as they went down a ramp. And so the ramp would have different thicknesses or different grits of sandpaper covering it so that we could measure and find some different coefficient of friction, that mu k, as you might remember. So we angled this ramp at 15 degrees. So the slope was 0.97 meters, and at the top of the slope, we would let off these two different vehicles, right? So here are the different sandpaper thicknesses. We got 80 grit, 150 grit, and then we just used the bare surface. So we let these cars roll from the top of the ramp, and we stopped recording once the slope ended. Again, we attached these different kinds of sandpaper to the board for the cars to go along. And we also just had a bare surface so we could see what we were working with without any sort of a grit, Once we took these videos, we could put them in the tracker, use that data in Excel, find max velocities, and then we wrote a little MATLAB code that would spit out the numbers we wanted. So here's a little video just setting up the basis of the project. It's the lighter car. All right, and now we're going to cut this video and add a different one where we show you guys what we did in Tracker. All right, so here we're using Tracker so that we can find the max velocity. First, we need to find the frames where the car's on the sandpaper. Let's give Tracker an idea of how far the car is moving. This is the slope you saw earlier. Setting a point mass to track throughout the video now. Alright, so again, here's what we used. We used Tracker on the left side. We entered this into Excel. Sort of complicated, but we were able to get some velocities and some pretty good numbers. We took these velocities, the weights, and here's a good look at some of the equations we had to use. So when we look at the weight, height, your MGH, we're talking about potential energy. We're trying to figure out the max velocity reached in some time frame from state 1 to state 2. And it was kind of cool how our MATLAB just let us just spit in these numbers, and then it would shoot back the friction factor, as you see here. So here were our findings. As we could see, as you progress to the higher grit, the max velocity reach was much lower. And, this is because the grit was applying a greater friction force against the cars. And while we did expect this, there were some things we weren't entirely sure about. Each car had a different kind of path as it went down that we couldn't really get to go straight. And also, as we sat out and tried to, write out what we thought was going to happen in this presentation, we were kind of surprised because although the white car was lighter, we sort of just looked at the heavier car, the orange car, and thought because of drag and turbulence and other fluids terms that maybe this car was going to have faster velocity somehow because it was having more potential energy at the top and in the shape of the car. And maybe there were some inaccuracies in our measurements. Trackers' reliability can vary because the camera quality has different levels of precision, and we weren't able to exactly calibrate the tracker each time. And as far as the grit of sandpaper, we had to lay out several pieces, and each piece may have some different level of grit. Every manufacturing process will vary in some way. And just by using all of these different apps, we were able to pull in a bunch of skills from a bunch of different courses, but we also depended on calculations from 3 different platforms, which could have eventually stacked tolerances and messed up our results. So as a conclusion, we still consider this a pretty good experiment of the friction factor we found. And again, we would like to address those limitations and see if what we were doing was a really good experiment and yielding good results. But as it turns out, the higher the grit, the larger resistance, and the slower velocities. So thank you guys. That's been our presentation, and we will see y'all next year.